Swayam Prabha. Digital India. Educated India.
Welcome back to the course Geology and Soil Mechanics. So, due to some unavoidable circumstances, I was not able to give the lecture in few weeks, last few weeks. So, last few weeks I hope that you have enjoyed the problems, okay. So, whatever numerical problems was solved by the student tutor, I hope that you must have enjoyed that. Now again we are coming back to this particular topic. So, we stopped here. So, when we were talking about the active earth pressure on the retaining wall, right. So, already we have seen that how the pressure, lateral pressure will be getting developed on the wall, and what are the different kinds of pressures generally developed on the wall, like active earth pressure rest condition, and passive earth pressure, right. So, this is purely based or purely dependent on the movement of the wall. That means, if the wall is moving away from the backfill, you will be getting the active state, and whatever pressure will be getting developed on the wall, that will be known as the active earth pressure. Whereas, if the wall is not moving at all, it is completely under rest condition, then whatever pressure will be exerted on the wall, that will be known as passive earth pressure rest condition. And if the wall is moving towards the backfill, that means you are pushing the wall towards the backfill, then you need more movement, and because of that whatever pressure will be getting developed, that will be known as passive earth pressure. So, with that we stopped. So, and we talked about this thing in the last lecture, that this is the Mohr cycle representation for active and passive earth pressure. So, first one we will be talking about the active state, and we will be trying to obtain the active earth pressure coefficient, and earth pressure coefficient is nothing but sigma h by sigma v, where sigma h is the horizontal pressure and sigma v is the vertical pressure. So, this is the constant expression for the earth pressure coefficient. Now, whatever may be the case, we will try to find out the lateral pressure, that is sigma h, and we will try to find out the vertical pressure, that is sigma v, and we will take the ratio to get the earth pressure coefficient at the corresponding state. Okay. So, suppose if I want to find out the earth pressure coefficient at active state, that means in the active condition we will try to find out sigma h, that is the horizontal pressure, and sigma v, that is the vertical pressure, and the ratio of these two will be giving you the earth pressure in active condition. Okay. So, now basically this CE is your the Mohr cycle representation for the active earth pressure. So, from the Mohr cycle, major principal stress sigma 1. Now, what is the major principal stress in case of active state? Suppose you have the retaining wall, okay, and the wall is moving away from the backfill. So, this is the backfill soil, okay, which is lying behind the wall. Now, wall is moving away from the backfill. So, slowly or gradually, you might have seen that thing in the previous lecture, that gradually when the wall moves, your pressure is decreasing, right. So, your pressure is decreasing on the wall. Now, when the wall is moving, so that means your at any section of the wall, if you consider, at that point whatever vertical stress will be there, that will be nothing but your major principal stress, right, because on that plane you do not have any shear stress. So, that horizontal plane will be the major principal plane, and on which your major principal stress is acting, and that will be in the vertical direction, right, in case of active state. So, okay. And so, as wall is moving, so your pressure is decreasing in the lateral direction, am I right? You have the wall at rest condition, wall is moving away from the backfill. So, slowly your earth pressure, that is the lateral earth pressure, is getting reduced, right. So, that means you are starting at that time there is some vertical stress on any horizontal plane at any depth below the ground surface on the wall. Okay. So, that is your vertical stress. So, that will be becoming the major principal stress, and as the stress is decreasing in the lateral direction, as the wall is moving, stress is also decreasing. So, that will be becoming your minor principal stress, right. So, the horizontal stress or the lateral stress will be becoming the minor principal stress in case of active state, whereas the vertical stress will be the major principal stress in case of active state. Agreed? Okay. So, the major principal stress sigma 1 is nothing but OP1. So, this is your O means origin and this is the point P1. Okay. So, OP1 is the major principal stress and that is nothing but your sigma z, that is the vertical stress at that point, okay, and is equal to gamma z, and where z is the, that is any depth below the ground surface along the wall. Okay. So, z is 0 means top of the wall, z is h means bottom of the wall. Okay. So, it varies from 0 to h, z is varying from 0 to h. Okay. So, now minor principal stress, that is nothing but the lateral stress, as I told you. So, the lateral stress, that is sigma 3, is nothing but OP2. So, P2 is here. So, OP2 is equal to sigma h, that is the horizontal stress. Okay. Now, from the Mohr circle representation, whatever Mohr circle we have drawn now, and this Mohr circle, because already we have seen that in case of active state you are getting the failure, right. Of course, the Mohr circle must touch the failure envelope. Okay. Agreed. So, Mohr circle, that is the maximum, I mean state of stress, possible state of stress in case of active state. Okay. So, OO1, okay, OO1 is nothing but sigma 1 plus sigma 3 by 2, that is the distance between the center of the Mohr circle from and the origin of the plot. Okay. So, sigma 1 plus sigma 3 by 2. Similarly, O1 C1, what is O1 C1? C1 is the point where the Mohr circle at active state is touching the failure envelope. So, O1 C1 is nothing but the radius of the Mohr circle, and that is nothing but sigma 1 minus sigma 3 by 2. So, we have seen these things several times when we talked about the shear strength of soil. Okay. Now, from triangle O1 C1. So, if you form a triangle with these points O1 and C1, from there we can write sigma 1 minus sigma 3 by 2, that is nothing but the radius of the Mohr circle, is equal to sigma 1 plus sigma 3 by 2 into sin phi, where phi is nothing but the angle of internal friction. So, this angle is phi. Okay. So, from this we can write sigma 1 is equal to 1 plus sin phi by 1 minus sin phi into sigma 3. From this relation we can get it. So, what is sigma 3? Already we have discussed, sigma 3 is nothing but the minor principal stress. In which direction it is acting? It is acting in the horizontal direction. So, sigma 3 is nothing but sigma h, and what is sigma v? Sigma v is nothing but major principal stress, that is nothing but sigma 1, right. So, sigma 1 is nothing but sigma v and sigma h is nothing but sigma 3. So, from the previous expression we can write sigma h is equal to 1 minus sin phi by 1 plus sin phi into sigma v. Now, if you see this relation, relation, now any situation earth pressure coefficient is nothing but sigma h by sigma v. So, this relation is constant, this relation is valid for all kind of state of stress, right, whether it is active, whether it is passive, whether it is rest, whatever may be the case. So, k is nothing but sigma h by sigma v. So, now from this expression I can write, so sigma h, this is nothing but sigma h is equal to ka into sigma v, yes or no, right, where ka is nothing but the earth pressure coefficient at active condition or simply active earth pressure coefficient, and that is nothing but 1 minus sin phi by 1 plus sin phi, right. So, we have seen this thing in the last lecture. So, once again due to for the continuation we just started from this. So, earth pressure coefficient in active condition is nothing but 1 minus sin phi by 1 plus sin phi. So, if you know the angle of internal friction of the soil, okay, so you can find out Ka. Agreed? So, no other parameter is coming into the picture, please try to understand. So, whatever may be the soil, if you know the phi, okay, from some laboratory experiment or field experiment, you need to find out phi. So, once you know phi, you can find out the active earth pressure coefficient from this expression. Okay. Now, we are going to the passive state of stress. Now, in case of passive state of stress, so we are having already we know in case of active state whatever pressure is exerted on the wall, okay. In the passive state you will be getting more pressure on the wall, right, as compared to the active state. So, and whether you consider active state or passive state, your vertical stress will be remaining same. What is the vertical stress? Gamma into z. At any location z, your vertical stress sigma v is constant, that is gamma z. Now, in case of active state, you start, this is your vertical stress P1, P1 is the point which will denote the vertical stress. Okay. Now, in case of active state, that P1 point was representing the major principal stress, because in the active state your lateral pressure is getting reduced, but in case of passive state your lateral pressure will be getting enhanced, getting increased, right. As you push the wall towards the soil, you need more pressure on the wall to push it to have the movement in the backfill side. Okay. So, you will be getting more pressure, and still your vertical plane or the horizontal plane will be remaining as principal planes. So, now when you are pushing the wall towards the backfill, try to understand physically, at that time at any location z, your vertical stress will be same, see, gamma into z, but your horizontal stress or the horizontal pressure will be getting increased, right. So, that will be becoming the major principal stress. In case of active state, the vertical stress was the major principal stress, and due to the reduction in the lateral pressure, you got the lateral pressure as the minor principal stress. But in case of passive, it will be just reverse. That means, in case of passive, your vertical stress, that means on the horizontal plane whatever stress is acting, that vertical stress will be becoming the minor principal stress, whereas you are pushing the wall and you will be getting much more increased lateral pressure, that will be becoming the major principal stress. Okay. So, just reverse. Okay. So, now basically the thing is that in case of passive state, if you consider any soil element, so this will be the direction of major principal stress, this will be the direction of minor principal stress. This is for passive. In case of active, this was your sigma 3 and this was your sigma 1, that was for active, right, already we have discussed. So, now we are going to consider this configuration. Okay. Now, the major principal stress sigma 1 is nothing but OP3. Now, which is the Mohr circle for the passive state? So, this is the Mohr circle. This is CP is the Mohr circle which will be representing increased stresses on the soil element. Okay. So, this point is fixed because you are not going to change the vertical stress, rather you are going to change the lateral stress. So, OP3 is the major principal stress, that is nothing but sigma h, that is acting in the horizontal direction as we have seen here, and is nothing but the passive pressure PP, that is nothing but your passive pressure, right. Lateral pressure is nothing but your earth pressure. So, sigma h is nothing but your passive pressure. Okay. So, what I mean to say that sigma 1, I do not know what is the magnitude of PP, right. I know the vertical stress only, and which is eventually sigma 3 in case of passive state. So, minor principal stress is nothing but sigma 3, that is OP1, that is constant, that was constant for active as well as for passive, and that is nothing but sigma V, which is equal to gamma into Z. Okay. So, I have got sigma 1, I have got sigma 3. So, from this relation, so sigma h is equal to 1 plus sin phi. So, now if you see this Mohr circle, so basically this is the point where the passive Mohr circle is touching the failure envelope, that is P3C2. Okay. P3C2, I mean this is the plane, but whereas the C2 point is the point where the Mohr circle for the passive case is touching the failure envelope. So, similarly, I mean by similar exercise whatever we have done for the active state, by considering the radius, by considering the distance from the origin to the center of the Mohr circle, all those things if we satisfy, we will be getting a relation between the lateral pressure and the vertical pressure like this: sigma h is equal to 1 plus sin phi by 1 minus sin phi into sigma v. Now, again we know sigma h is nothing but k into, this is for passive case, right. Sigma h is nothing but k p into sigma v, where k p is nothing but the passive earth pressure coefficient, and which is nothing but 1 plus sin phi by 1 minus sin phi. Now, you see k p is much more larger than k a, and which will tell you that active earth pressure will be always lesser than your passive earth pressure. Okay? I hope you have understood this thing. So, whenever you will be getting this kind of situation, whether you need to calculate the pressure under active state or under passive state, you need to find out the soil friction angle, that is angle of internal friction of the soil phi. Once you know phi, immediately you can calculate K p or K a as per your requirement. Okay. Now, we will see few cases where you have different soil conditions in the backfill side, and based on that whatever pressure you will be getting on the wall. So, that we are going to find out. Now, if you have dry backfill soil, now your backfill is completely dry, there is no water at all. So, if that situation persists, then basically this is the wall, okay. This is the height of the wall is capital H, and A is the bottom of the wall, B is the top of the wall, and this is the failure surface, okay. This is the failure surface, Rankine failure surface, already we have seen in the previous lecture. So, now if I want to find out the active earth pressure, okay, on this, or the distribution of active earth pressure on this wall, then how I will find out? So, as you know, your active earth pressure P a is equal to K a into gamma z, where gamma z is nothing but sigma v and P a is nothing but sigma h, right. So, you know already we have discussed enough about this. So, now this, when z is 0, what is the active earth pressure on the wall? Z is 0 means the top of the wall. So, active earth pressure is simply 0. So, that is nothing but this point. Okay. Now, when z is equal to h, that means at the base or at the bottom of the wall, at the time what is the active earth pressure coefficient, active earth pressure value, that is P a is equal to K a into gamma into h, right. So, this is the point, and it will be connected with a linear variation. So, this is a linear variation, right. With z, P a is having the linear relation. So, this K a into gamma h is equal to the active earth pressure which is acting at the base of the wall, and from 0 to h, this is the variation of the active earth pressure, triangular distribution, the triangular pressure. Okay. Now, I mean what is the difference between water pressure and this active, I mean soil pressure? So, water pressure, as you go on increase the depth, basically you will be getting h into gamma, right, gamma into h. So, at that time at any location you consider at that point, so you will be getting same amount of pressure, that is your hydrostatic pressure. So, instead of this gamma into h, in case of soil you are getting K, one more term you are getting, that is taking care of the earth pressure coefficient. Okay. So, that is the only difference. Okay. So, now if I want to if I want to find out the total thrust, active thrust or the total force, active force acting on the wall, say P a, what is P a then? P a is nothing but the area of the triangle. This triangle is nothing but the pressure distribution. So, area of this triangle will give you the total active thrust on the wall, that is nothing but area of the triangle is half into K a gamma into h into h. So, half K a gamma h square. Okay. So, that is nothing but your P a. So, this I show with small pa, that is nothing but the pressure, and capital Pa is the total thrust. Now, once I calculate this, so that is the total force acting on the wall, and your wall should be designed based on this total force. Now, you may think of that as the pressure distribution is not uniform, this is a linear distribution, right. So, you will be having less section at the top if you think of your reinforced concrete design aspect. So, you will consider less thickness at the top and higher thickness at the bottom, because maximum pressure has to be resisted at the base. Okay. So, these are the things will give you the idea that how you can design your retaining wall. Okay. Now, this Pa is the total active thrust. Why it is acting? It is acting at the center of gravity of this triangular area or CG of this triangular area. Okay. Now, this distance is what? H by 3. Okay. So, this Pa will be acting at H by 3 from the base. Agreed? So, you know the whole thing now. You know how to calculate active earth pressure, you know how to obtain the active earth pressure distribution, you know how to calculate the total active thrust from the distribution itself, and you know the line of action of the total active thrust, right. So, everything is known to you. Similarly, in case of passive pressure, okay, so passive pressure will be generally larger. So, in case of passive pressure it will be remaining same. In case of passive pressure, what is the passive pressure expression? Pp is equal to Kp into gamma into Z, right. So, Kp if I know, I can find out the passive pressure. Now, here also you see the relation between the passive pressure and the Z is nothing but linear. So, at Z equal to 0, what is the magnitude of the passive pressure? Simply 0. At Z equal to H, what is the magnitude of the passive pressure? Kp into gamma into H. So, that is here, and within these 2 points you will be getting the linear variation, linear distribution, am I right, as very simple as active state. Okay. So, and the total thrust Pp will be nothing but the area of this triangle, that is nothing but half into Kp into gamma into H square, which will be acting at H by 3 distance from the base. Agreed. So, if you have dry backfill, there is no water at all. If water is there, water pressure has to be considered separately. So, if there is no water at all, then basically this is the pressure distribution under active state and under passive state, and you will be getting all information like what is the total thrust, what is the line of action of the total thrust, all those things from this distribution itself. I hope you have understood now. Okay. Now, another case we will be considering when you have submerged backfill, that means water table is at the top of the wall. Okay. Water table is at the top of the wall, completely submerged back. Now, what is happening here? Okay. Now, we will be considering only active state, the passive state will be just same, okay, like active state, only difference you will be considering, that is the earth pressure coefficient. Instead of active earth pressure coefficient, you have to consider passive earth pressure coefficient in case of passive state, that is all. So, we will be talking about only active state, let us say, and passive state already you can find out. Okay. So, same thing, the same wall, say the height of the wall is capital H, A is the base of the wall, B is the top of the wall. Now, here you have, you do not, I mean earlier case we had the dry backfill, I mean water was not there. Now, in this situation you have the backfill which is completely submerged in water. Okay. That means, you have soil as well as water. So, you will be getting the lateral pressure under active state, you will be getting the pressure due to water as well as due to the soil. Now, when you are considering the soil, then you will be getting the active thrust or passive thrust depending on the situation, but in case of water it will be giving you the hydrostatic pressure, simple. There is no active, there is no passive in case of water pressure, right. So, it will be giving you the all round hydrostatic pressure. Okay. So, in case of active state still we can consider that. Okay. So, your sigma V is nothing but gamma prime Z. What is gamma prime? That is the submerged unit weight, right. In case of submerged backfill, you have to consider submerged unit weight. So, sigma v is nothing but gamma prime Z. So, if you know this, you can find out Pa, that is Ka into sigma v, that is nothing but gamma prime Z. So, at Z equal to 0, Pa is 0, at Z equal to H, Pa is Ka into gamma prime into Z. Okay. And distribution is again linear. The total thrust will be the area under this distribution, under this triangular distribution. So, that is nothing but Pa, and you know the line of action. So, this was the situation in case of dry state. Now, you are considering submerged backfill. So, in addition to this pressure, you will be getting another pressure which is coming from the water, simple from the water. So, water pressure is nothing but, you know, at top it is 0, at bottom it is gamma W into H, and that distribution again is triangular. So, total thrust on the wall is nothing but Pa plus Pw. Okay. Both are acting at h by 3 distance from base, right, agreed. So, this is the term, this is the thing which is coming extra because you are considering submerged backfill. Understood? Okay. Now, we will see the next case where you have some amount of soil is submerged, some amount of soil is not submerged. Let us see what is happening. Backfill is partly submerged with a uniform surcharge. Now, you have the surcharge as well as your submerged condition. Now, let us understand this problem. The problem is the total height of the wall is capital H, up to depth H1, capital H1, the soil is not submerged. From H1 to H, okay, that means the total depth H2, this soil is completely submerged. So, water table is here. Okay. So, when we are considering H1, at that time we will be considering the dry soil, and when we will be considering H2 soil, H2 portion, then the soil will be completely submerged. And apart from that, you have some surcharge load, that is Q, that any kind of pressure, it could be any structure or any foundation or any kind of say road or embankment, whatever, that is on top of this surface, and which is giving you the uniform surcharge pressure, that is Q. Okay. So, now for Q, what will be the earth pressure? Q is the vertical pressure. Now, whatever depth you consider along this wall surface, whatever depth you consider, Q will be remaining same, Q will be remaining Q itself, right. But what will be the magnitude of the lateral earth pressure? In case of active state, that will be Ka into Q. Ka is your active earth pressure coefficient, multiplied by Q will be giving you the lateral pressure, because your sigma H is equal to Ka into sigma V. Here sigma V is Q. So, sigma H, that is the active earth pressure due to surcharge, will be equal to Ka into Q, simple. Okay. And that will be nothing but a rectangular distribution. So, it is constant. At top it is also K into Q, at bottom it is also K into Q. Okay. And the total thrust PQ will be acting at the midpoint. So, this is nothing but your H by 2. Okay. So, at the midpoint of the wall PQ. Okay. Now, coming to the actual soil earth pressure. So, from 0 to H1, okay, you have the dry soil. So, at 0 you will be having active earth pressure equal to 0, at H1 you will be having active earth pressure equal to Ka into gamma into H1. Okay. So, this is the distribution, fine. Now, from H1 to H2, at H1 you are having K into gamma into H1. Now, at H2 what will be your pressure? At H2 you will be having the pressure at Ka into gamma prime into H2, because you have to consider the submergence, right. The soil is submerged from H1 to H, right. So, at the depth H2, the whole depth the soil is completely submerged. So, that depth is basically Ka into gamma prime into H2. So, that will be the pressure. So, this is the total pressure distribution, okay, bilinear distribution. So, the total thrust, if you want to calculate the total active thrust, basically that will be nothing but the area of this bilinear distribution, okay. And at the bottom the total pressure will be Ka into gamma H1 plus Ka into gamma prime H2, that is the total pressure acting at the base of the wall. So, this Pa is the total thrust. Now, how I will find out the line of action of this Pa or the point of application of this Pa? So, point of application, if you want to find out, you have to find out the Cg of this bilinear distribution, and you know how to do that from your mechanics of solid or strength of materials course, right. So, you find out the Cg and that will be your point of application of Pa. Okay. Now, that is not enough, because soil is partly submerged. So, you have to have the water pressure plus this is the water pressure. So, water is from H1 to H. So, H1 to H is your water pressure, and at H1 you have water pressure is 0, at H your water pressure is gamma W into H2. Okay. So, that is your water pressure, that is Pw, and that is acting at the Cg of this triangular distribution. So, backfill, when the backfill is partly submerged, so your total thrust Pa bar saying is equal to Pq, that is the active thrust due to the surcharge, plus Pa, that is the active thrust due to the soil only, plus Pw, that is the pressure, water pressure, okay, due to the submergence, okay, that during that within that zone. So, point of application of Pa, so you can calculate the point of application separately, that is Pq, as I told you, Pq is acting at the midpoint of the rectangular distribution, Pa is acting at the Cg of this bilinear distribution, and Pw is acting at h by 3 distance from the base of the triangular distribution. That is the line up or the point of application of different active thrust. Now, if you want to find out the point of application of the total active thrust Pa above the base of the wall, so then it can be found by taking moments of all the forces acting on the wall about A. So, that means you have this, you have this, you have this. So, you have this for water, okay. So, which is starting from H1 to H, okay. So, you are getting Pq, you are getting Pa, and you are getting Pw, okay. Now, this, so you know the point of application of each individual thrust or each individual force, okay. So, you can take the moment of all the forces, because if you know this is say Zq, this is say Za, and this is say Zw. So, if you know the distances, if you know the point of application of each individual force, you can find out the point of application of the total thrust Pa bar, okay, total thrust Pa bar by considering the moment with respect to the base of the wall, okay. And you can say, okay, so this is my wall, Pa bar is acting here, which is a distance Z. So, Z can be calculated by taking the moment with respect to the base of the wall. Now, so far we have seen, okay, if you have the cohesionless soil, that means C was 0 in that situation. If you have the cohesionless soil, then basically how we have got the distribution, pressure distribution on the wall, and how we could calculate the total active thrust or passive thrust on the wall, right. Now, most of the situation you will be having soil which is C phi soil. So, you will be having cohesion as well as phi, right. So, if you have the cohesive soil, that means C is there as well as phi is there, at the situation how you can find out the active earth pressure or passive earth pressure. Okay. So, that we are now going to look at. Okay. Now, in case of this, whatever may be the case, sigma v is gamma z, that is the vertical pressure at any depth z will be gamma z. There is no issue for that. Okay. If the soil is completely dry. Okay. Now, tau f, that is the shear strength. Already we have seen that thing in the shear strength chapter, that tau f is equal to C plus sigma tan phi, where C is the cohesion, sigma is the normal stress on that particular plane, and phi is the angle of internal friction of the soil. Now, we know from our earlier say calculation or derivation, when we talked about the shear strength of soil. So, sigma 1 is equal to sigma 3. So, we got this kind of expression, tan square alpha plus 2c tan alpha. Instead of tan alpha tan square alpha, I am writing n phi. So, n phi is nothing but tan square 45 plus phi by 2, which is nothing but 1 plus sin phi by 1 minus sin phi. So, that is sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. So, instead of tan square alpha, I am writing n phi, and instead of tan alpha, I am writing root over n phi, okay, where n phi is given by this expression. Already we have seen that, already we have discussed enough on this expression. Now, in case of active case, in case of when we are talking about the active state, sigma 1, what is the major principal stress? That is nothing but the vertical stress, already we have seen, that is nothing but gamma z. Now, what is the minor principal stress? That is nothing but sigma 3, which is nothing but the horizontal the lateral stress, lateral pressure, and that is nothing but your active earth pressure, Pa. Okay. So, therefore, Pa is equal to gamma z. So, I am putting this thing in this expression. Okay. So, Pa, what is Pa? That is nothing but sigma 3 in case of active state. So, Pa is equal to gamma z by n phi minus, what is gamma z? That is sigma 1, right. So, from this expression, if you want to write sigma 3 is equal to sigma 1 by n phi minus 2c by root over n phi. So, same thing we are applying here. Okay. So, Pa is equal to gamma z by n phi minus 2c root over n phi. Okay. So, which is nothing but gamma z into Ka. You look at here, what is n phi? N phi is nothing but 1 by Ka, or Ka is equal to 1 by n phi. Already Ka already we have calculated, that is 1 minus sin phi by 1 plus sin phi, that is not going to change. Only thing is that pressure distribution will be going to change, and that we will see. Okay. So, Ka or Kp value will be remaining same. Okay. That is nothing to do with whether it is you are considering cohesive. I mean, it could be a good question, right. If you deal with cohesive soil, what is the magnitude of your earth pressure coefficient in the active state or passive state? That will be remaining, that will be completely dependent on the angle of internal friction soil, that is phi. Okay. So, gamma z into Ka, this is nothing but this, and 2c by root over n phi is nothing but 2c into root over Ka. Okay. Now, the active pressure Pa is equal to 0 when? So, this was the expression. This was the expression for Pa. Pa is equal to gamma z into Ka minus 2c into root over Ka. Now, when the active earth pressure will be becoming 0? Let us see. Earlier case, in case of purely cohesionless soil, okay, at that time the active earth pressure or passive earth pressure was becoming 0 at the top of the wall, because Pa or Pp was equal to K into gamma into Z. If Z is 0, simply it was becoming 0. Now, whether that situation still valid or not, that we have to examine, right. So, in case of active pressure, say when PA is becoming 0, at that time what is happening? Say gamma z by n phi minus 2 c by root over n phi is equal to 0 from the previous expression. Okay. From this we can find out at which depth PA is becoming 0. So, z is equal to some depth, say z naught, okay, is equal to 2 c by gamma into root over n phi. Okay. So, that means if you have the wall like this, so at z equal to 0 it is not becoming 0. Earlier case, in case of cohesionless soil, we have seen that earth pressure was becoming, lateral earth pressure was becoming, whether it is active or passive, it was becoming 0 at the top of the wall when z equal to 0. But here when you are considering the cohesion of the soil, at that time you can't say simply that if z becomes 0, my pressure is also becoming 0. No. Rather, in case of active state, you are seeing this when z is equal to some value of z naught, okay, which is nothing but 2 c by gamma into root over n phi. At that distance, some distance, say this is your z naught, at some distance from the top of the wall, okay, your earth pressure, active earth pressure is becoming 0. This is the basic difference, okay, between the cohesionless soil and cohesive soil. So, in case of cohesive soil, just at the top of the wall you are not getting 0 active earth pressure, you will be getting something else, we will come to that point later on, but you will not be getting 0 active pressure at the top of the wall, rather you will be getting 0 active pressure at some depth below the top of the wall. Okay. So, at depth z equal to, then what is happening at z equal to 0? So, you are saying that at z equal to z naught you are getting active earth pressure is 0. Now, what is happening at the top of the wall? Okay, let us see, let us examine. So, at depth z equal to 0, the pressure Pa is minus 2 c by root over n phi. Now, c is positive, n phi is positive. So, Pa is becoming negative, that means active pressure Pa is tensile, because already we have considered that our compressive stress is positive in soil mechanics, as I told you several times previously. So, when you are getting negative pressure, that means it indicates that you are getting, or you are developing some tensile pressure or the tensile stress, okay, at the top of the wall. So, active pressure Pa is tensile between depth 0 and z naught. Understood? So, if I want to, this is say z naught depth. So, if I want to obtain the pressure distribution, so this is my negative. Okay. So, it is 0 at z equal to z naught, okay, and this is negative 2 c by n phi, this is negative. So, from top to z naught distance, z naught depth, you will be getting tensile stress or the tensile pressure. Understood? Okay. Now, you see the distribution. Okay. So, this is the wall, this is the total height of the wall h. Okay. So, as I told you that when z equal to z naught, so z equal to z naught, you are getting active earth pressure is 0. At z equal to 0, that means at the top of the wall you are getting 2 c by root over n phi, which is nothing but tensile minus. Now, from this point onward you will be getting k into, this the distribution, whatever magnitude you will be getting. Okay. So, that is valid from this. So, from this to this you will be getting this. So, at bottom you will see gamma h into n phi. So, at z equal to h, what is happening? So, from the expression, from the expression itself you can see at z equal to h, that will be gamma into h into Ka minus 2 c into root over Ka. right. So, that I am showing here. Okay. So, this is nothing but the total minus 2C. So, this is the total minus 2C. So, this much will not be there. So, this is the total pressure distribution. So, this hatched part is the total pressure distribution, that is the compressive stress or the compressive pressure thrust. Okay. So, and so what does it mean? So, this is compressive, this is positive, this is negative. Now, if you consider, and they are symmetric, right. So, this triangle and this triangle both are symmetric, agreed. Now, from z equal to 0 to z equal to 2 z naught, which is nothing but say AC, which will be coming later on. So, from z equal to 0 to twice z naught, within this distance, this negative triangle or the negative pressure will nullifying this positive pressure, agreed. So, there will be no pressure at all. From z equal to 0 to z equal to twice z naught, you do not have any pressure. Okay. So, now total active pressure, I mean this PA, okay, the total thrust, if you are going to find out, that is nothing but 0 to h, okay, P into Z into dz, which is nothing but 0 to h gamma z by n phi into dz minus h by 0 into 2c h by integration 0 to h 2c by root over n phi into dz. So, this is nothing but PA, right. So, if I say this is PA, this is PA. Okay. So, now PA into Z, that, and PA already we have seen that gamma z by n phi minus 2c gamma z by n phi, already we have seen that 2c by root over n phi. Okay. So, into Ka, that should be, so 1 by n phi is nothing but your Ka, already we have seen. So, this already we have seen, that is nothing but PA. Okay. So, if you do this integration, both the integrations, basically you will be getting the total thrust that is PA is equal to half into gamma h square into 1 by n phi minus 2c into h by root over n phi. Okay. Now, the shaded area gives the total pressure PA. The previously whatever shaded area we have seen, this is the shaded area. So, this area if you calculate this area will give you the total active thrust in case of cohesive soil, okay, and which is obtained from this expression, from this integration, right. So, total thrust you can calculate. So, at this is the total thrust acting at some points, that point of application needs to be calculated, that is different issue, but the thing is that this total thrust, how you will find out this total thrust, that is the total pressure, that is nothing but the shaded area. Whatever shaded area I have shown you in the previous slide. Now, if total earth pressure is equal to 0, if this total thrust is becoming equal to 0, what is happening? So, if it is becoming 0, so this is also becoming 0, then I can find out, because already we talked about that, right, when z equal to twice z naught, right, do you remember, right. So, at that time the negative part, negative triangle and the positive triangle, they will cancel each other, right. So, the total thrust from 0 to that depth twice z naught, you will be getting 0, you will be getting some negative stress, negative pressure, and you will be getting some positive pressure, they will be cancelling each other and total thrust will be equal to 0. That is physically you can explain, but mathematically or the expression, or when you are developing the expression at that time, at that depth, up to that depth actually 0 to HC, okay, is equal to AC, where AC is nothing but twice z naught, say already we have seen that. So, when Hc is equal to 4 C by gamma root over n phi, at that time you will be getting total thrust equal to 0, because the negative part and positive part will be cancelling each other. So, Hc is very important in soil mechanics. So, Hc is known as critical depth. Okay. So, this is very important. Now, this indicates that a vertical bank of height smaller than Hc can stand without lateral support. That is why if you want to excavate, okay, in sandy soil, in cohesionless soil, okay, basically you cannot excavate without giving any vertical support. So, you need to give the vertical support, otherwise soil will collapse in the excavation. But if you, I mean, you might have seen that thing in your day to day life, or in your physical or the practical experience you have gathered, that if you want to excavate anything in C5 soil, okay, when you have some cohesion, you can get some amount of say vertical cut which can stand without any support. You need not to give the lateral support, that means bracing or all those things, right. So, those things are not required. So, certain depth will stand without any support. Now, what is that certain depth? That certain depth will be lesser than the critical depth Hc, because you do not have any pressure. So, if there is no pressure, that soil will be standing without any pressure, that the earth pressure at rest condition. So, there is no wall required at all. Okay. Soil is standing without any active or active thrust. So, it will be considered as active earth pressure at rest condition kind of thing, right. So, there is no movement. So, that is why in case of C5 soil, any a certain depth or certain bank of height smaller than Hc can stand without any lateral support. Okay. So, soil does not stand any tension, already we have talked about this thing. Soil can take care of compression, but it is very weak in tension. So, soil cannot take care of tension. Soil does not stand any tension, and as such it is quite unlikely that the soil would adhere to the wall within the tension zone of depth Z0, producing cracks in the soil. Okay. So, what does it mean? What is the meaning of this statement? Say you have the wall like this, okay, and you have seen so this is your Z0. So, within this depth 0 to Z0, basically you are getting tension, am I right? Soil is experiencing some tension. Now, soil cannot take care of any tension, agreed. Soil cannot take care of any tension. So, that means the tension means it will try to adhere the wall, right, that soil cannot take care. Soil cannot produce this kind of adherence, right. So, this I mean, so if you want to adhere the wall, I mean something like your tie rod or something like your rope, you are just I mean just pulling the wall back. So, that pulling or that kind of situation may not have, I mean will not happen in soil. Soil cannot take care, or soil cannot suck, or soil cannot pull the wall back. Okay. So, therefore, what happens, you will be getting some tension crack within this zone 0 to Z0. Tension crack means you might have seen this thing. So, if the wall is constructed, you will be getting some cracks. Okay. So, this is known as tension crack, okay, and this will be only up to depth Z0, because soil cannot take any tension. So, it will be having the crack or the fracture, okay. It cannot pull the wall back. So, this is very important, and that is why you might have observed this thing, okay, but you observe this thing without knowing. Now, you know why this kind of tension crack is really happening in the soil. So, you will not be getting this kind of tension crack in cohesionless backfill. You will be getting tension crack in cohesive backfill when you have cohesion, because you are getting some development of tension at the top portion or the top part of the wall. Okay. So, I will stop here today. In the next lecture, we will be continuing this thing to understand this phenomena in more precisely, and then we will be talking about in case of rough wall. So far we are considering the smooth wall, right, the wall surface is smooth. Okay. So, if you consider the rough wall, what will be happening? So, that was proposed by Coulombs. So, that we will be discussing later on. So, I will stop here today. Thank you very much.